This is the formula for finding the arc length of a curve. It's very straightforward to use, so we'll just discuss the principles on which it operates. It's a calculus problem, and what's going on is, in order to get this arc length, what we're going to do is basically find the distance between points on the curve and then add them up. If I were to divide it up into these 8 points and add these up, this would give me an approximation of what that arc length would be. But as I divide them up into infinitely many points, as I make the number of points go to infinity, then it's going to approach closer and closer to the actual arc length of this curve, and that limit will be the arc length of that curve. So the length is the limit as n goes to infinity of the sum of the points. And now we're just going to start replacing stuff. What we're doing here is using the distance formula, so I'm going to replace this part, this. This is going to be the equal to yeah. So it's just taking the point minus the previous one. So if it was I was 1, and it would take, well, I did it wrong. Well, I started with 1, but it basically, let's say I was 2. Then it would be 0.2 minus 0.1 squared, y2 minus y1. So the y of this point I mean, you already know how all this stuff works anyways, so I mean, that's basically what's going on. So then we are going to make some more replacements. I'll write this as, write the stupid delta. Next I'm going to make another replacement. I'm going to change delta y with, since delta y is equal to f of x I yeah, this is what this is equal to, right? So what we're going to do here is just replace this. And this x star is just, I'm just using these middle point things. That's what we usually do, yeah. I don't know why I even bothered to do this in the beginning. Probably should have switched that right away, but yeah, we're just going to center the points, makes things easier. But basically what this is saying is I can write y as the x value here minus the multiplied by the instantaneous rate of change. So we're replacing delta y with this notation as that's equal to the same thing. this y value is equal to delta x times whatever the instantaneous rate of change is, yeah. So, the point of it will be revealed. Man, I keep writing it backwards. It's just one of those days, you know. Write everything backwards day. Here, what is done is this delta x is factored out. So this leaves 1, and f prime. So this is just going to become delta x. Alright, so we successfully replaced this here. Now we'll put this back in. Oh, one more thing. Up here I just use the Leibniz notation. I mean, I can change this to the Leibniz notation as well. It's not a big deal. We'll leave it as is for now. And from here we can see that this is just a Riemann sum. So we can convert this to interval notation. And whatever, I'll just change it to Leibniz notation. That's all there is to it. It's pretty easy to get if you know what the principles it's working on are. It's just adding up all these little distances, and the limit as these distances become smaller and smaller, the points get smaller and smaller, then the limit's going to approach the value of whatever this length of curve is.